Okay, hello guys. So today we're going to solve this problem from LeetCode for problem number 456. That is 132 pattern. Let's see. So it's a medium problem and it's a pretty famous question as well. So let's see what is this problem about. So you're given an array of n integers nums. Okay, a 132 pattern is a subsequence of three integers. Okay, so you have three integers and nums of I, nums of j, and nums of k. Okay, so this is like n of I, this is like n of j, and this is n of k, such that I, j, and k. Okay, so I is greater than j and it's greater than this. So, for example, this is like an array, and this is I, this will be j, this will be somewhere k, and nums of I is less than nums of k, and nums of j is greater than nums of k. Okay, okay, so nums of j is the largest array, is the largest element. This is the largest element. And okay, so what this question means, so what this question is about is that you are given like these numbers. Okay, let's say a, b, and c. Okay, so the element in the middle will be greatest. Okay, the element on the rightmost side will be the second greatest. Okay, and element on the left hand side will be the smallest. Okay, so this is the question. That is why we are saying, okay, so that is why we said the 132, because first greatest, second greatest, and then third greatest. Okay, and we want to find if in a sequence, if we have this type of pattern or not. So let's see if we do have in this question, if we do have in this sequence or not. So it's 1 2 3 and 4. Okay, so now uh, I want to find a number which is greater than. Okay, so let's say that my, so this is like the three. So these are the those three, you know, integers that that I want to fit in this pattern. And I said that 1 is the first element. So I need elements that are greater than 1. Okay, so I will take 2. 2. And do we have any other element that is small, that is greater than 1 but smaller than 2? 3, it's greater than 2. No, condition is not satisfied. 4, 4 is also greater than 2. No, it's not satisfied. So now I will say that 1 is not the right answer. So I will take 2. Okay, 2. Do we have any element that is, you know, do we have any other element that is greater than 2? Yes, we have 3. Okay, so do we have any other element that is greater than, you know, like it should be smaller than 3 but greater than 2? 4, we only left with 4, but 4 is not smaller than 2, although although 4 is greater than 2, but it has to be smaller than 3. So 4 is not the right answer, so we won't be putting 4 here. Now another option is that you put 4 here, and now you may be thinking that I can put 3 here. Now this is a 1, you know, 132 pattern, but no, this is not satisfying the condition that I is smaller than j and j is smaller than k, because we have interchanged their position and that is not allowed. Okay, which is why this condition is not possible, and our answer to this question will be false, because we are not able to find any pattern in this test case which resembles to the 132 pattern. That is why we are returning false for this one. Then let's see for this example, 3142. Do we have any element that is, uh, you know, so this middle element, it's like the middle element has to be the greatest, right? So let's say 4 is the middle, and then we have now this has to be the second element. So I will take 2, second greatest element, and this has to be the smallest element out of the trio. So 1 will be here. Yes, we found our 132 pattern. So 1 is smallest, This is the second smallest, and this is the third smallest, which is why this is our answer. And we said that we have found a sequence like this, so we will be returning true. So we don't actually want to return the sequences. We want to return only a boolean value, that is true or false, if we have found them or not. Okay, so let's see. There are only two approaches which which I have came across. So the first approach is to use a three nested for loops. Okay, that is so this is our array of integers, and we start with I at this point, and for the elements in this subarray we start with j, and the elements in this subarray we start with k, and then we place a condition that if, and the condition is very much similar to what the question has imposed, that if nums of I is smaller than nums of k, and nums of k is smaller than nums of j. So if this is the case, then we will return true. Otherwise, we are going to get out of the loop, and when all of the iterations are done, we will simply return false. If we have not returned true in a loop, in our three nested loops, then we are going to return false. Okay, so let's see what the code is. So we are going to start from I is equal to 0, and j will be obviously as I plus 1, and k will be j plus 1. Okay, so it's like if this is the array, and this is I, this is j, this is k. In this way, we are very much sure that I will be somewhere here, and j always will be greater than I, and k will be greater than both of them, right? So this is a three nested for loops, and the time complexity for this one will be order of n cube, and space complexity will be order of 1. Not bad actually, but I mean space complexity is not bad, but time complexity is very bad, and we don't want that, right? So now you have to make some observations, and we have to optimize the solution. Let's see how we can. So the second approach is to optimize it. Let's see how we can optimize it. Yeah, so the very basic thing that I can observe here is that the elements that I am iterating over are somewhat dependent on the elements that have been iterated, that have been traversed earlier, right? When this observation, when I have observed this thing, then I was very much sure that maybe I have to use some data structure or dynamic programming. Well, in this case, dynamic programming is not that possible because we are not doing overlapping decisions, right? We are not dealing with overlapping decisions, but in this case we are dealing with something called somewhat dependency on the previous elements. So that is why we will be using stack. Let's see how we will be using stack. So this is our stack. Not really. uh, okay, so this is our stack, right? And let me run on a test case for you to understand. So the test case which I have devised is 47523. Okay, let's see. I'm also going to create a variable called third element so that I'm sure. So it's like this one. Okay, so third element is this variable. Third element is this one, and I'm going to tell you how we are dealing with these other two numbers of the pattern, of this pattern. Okay, I'm going to tell you how we are actually seeing them. So initially t was a minimum value, and why it's minimum? Because our constraints are set in such a way that we can have 10 raised to power minus 10 raised to power minus 9 values as well, minus 10 raised to power 9 values as well. Okay, so let's see how we can do this. Now I come to know that I'm working with third variable on the first basis. So I will be traversing this element, this array in the reverse order, which means from right to left. So now I am pointing on this element. Okay, I'll be storing it in stack because stack is empty. All right. And then I will be moving on to the other element. And now I'll see that 2 is smaller than 3. Okay, so if 2 is smaller than 3, I'll store it. No problem, I'll store it. And then I'll see that 5 is greater than 2. If 5 is, then I'm going to compare if the top element and the incoming element, if the top element of the stack and the incoming element which is meant to be pushed, I'm going to compare them. If the incoming element is greater and 5 is greater, right? 5 is greater than 2, then I will pop this 2 and I will give this 2 as the third element, and then I will check if 5 is also greater than 3. Yes, it is. So I will pop this 2 as, I will pop this out, and um, it was earlier 2 and now third element will be 3. So then I will store 5 here. Okay, so now you can understand and made an observation that the second element is the element that is on top of the stack, right? Yeah. So second element is on the top of the stack and the first element is the incoming element, that is nums of I. This is that incoming element which we are storing. So these are three elements that are now divided into their certain categories, and now we'll look into them. So now we have 5 and 3. Okay, now I will see 7. Well, 7 is, greater than 5, so I will pop this one as well and stores 5 here and 7 is placed here now. Okay, and now I will move this pointer to this one and I will see that 4 is greater than 7, not greater than 7, right? So 4 is not greater than 7, 4 is smaller than 7, and 4 is also smaller than third element. So if 4 is smaller than third element, then it's obviously smaller than the stack top because this element is the largest, is the greatest, right? This element is the greatest, and this element will be second greatest, and this element will be third greatest. So if we compare only these two, and the G3 is smaller than G2, then it's pretty much obvious that G3 is smaller than G1, right? So after comparing that 4 is smaller than this one, yeah, we have satisfied our condition, that is 4, 7 and 5. So this is our pattern which we needed, and we are going to return true that we have found the pattern. Let's see the code. So the code is, first of all, I'm going to initialize a third element variable with int minimum value, and then I'm also going to create a stack. After that, I'm going to iterate over the array in the reverse order, which means from right to left, from the last index element to the first index element. And then I will see that if it is, you know if the okay, so the first, this condition, I'm going to come back to this later on, but let's see. So if stack is uh okay, well, let's see, let's just follow the order. Yeah, so now if you will see closely that in the first case nums of I is smaller than third element. No, it's not, because this element is the minimum value, and by our constraints nums of I will always be greater than the minimum value. So this condition is not satisfied, so we move on to the other condition. And by the way, I'm doing this dry run for the, okay, 47523 for this test case. Okay, and this is our stack. Yeah. So now this is our stack, right? And let's see. So then we will jump on the while loop, and the while loop says that if the stack is empty, if stack is not empty and the top value is smaller than nums I, which means the incoming element is greater than the element that is on the top. So there is no element on the top, so this won't be run as well. So we'll jump to this one, and now we are going to store the this 3. Okay. So when we have stored it, now I'm going to move for other iteration, and now I'm pointing on this one. I is pointing on this way number, that is 2. So is nums I is smaller than no? I'm going to jump to this one. Now stack is not empty, yes, and the top one and nums of I is 2 and stack top is 3. So is 2 greater than 3? No. So we're going to move another again, and we are going to store it. Okay, this is the storing part, and then we're going to move to another variable, that is 5, another value of the array, that is 5. And is nums of I, that is 5, smaller than the minimum? No, it's not. So we're going to move another part, and that is stack is empty. No, it's not empty. Yes, condition is right. And stack dot top, is it smaller than stack dot top is 2, and this is 5? Yes, now this condition is true. 5 is greater than 2. So we will put this third element, like this third element value uh, as st dot top, which is 2, and we will pop this element out. We have popped it out, right? Now I'm going to push this element into the stack. Let's push this up. 5. Oh, actually it's a while loop, right? It's a while loop. So we will check again. The stack is not empty. Yes, it's not empty. We have 3, and stack dot top is 3 and we have 5. Is this condition right? Yes, it is right. So we will make a third element st dot top, that is 3, and pop it out. Now it's gone. And similarly, now the stack is empty, so we are not going to repeat this while loop again, and we're going to jump directly on this one, and we're going to store the value, that is 5, on which the pointer was pointing. And now we are pointing on 7. And is 7 smaller than the third element? Is 7 smaller than 3? No, it's not. So I will move further, and I will see that is stack empty? No, it's not empty. Okay, is stack dot top, that is 5, is it greater than 7? Yes, it is. This condition is right. So we will store the third element value. We will store the top value of the stack into the third element variable, that is 5, and we will pop it out. Now I will check again, but the stack is empty, so while loop won't be running again, and we are on this line. The control follows this line, and now we're going to push this into the stack. Now we are pointing on fourth fourth value of the array, or the first value of the array. And in this scenario, is nums of I, that is 4, smaller than third element, that is 5? Yes, the condition is true, which means that 4. So this is the nums of I incoming value, which I have told you earlier. This is 4, and the element in the stack is the largest, which is 7, and the third element which we are storing in a variable, that is 5. This is our 132 pattern, right? Because this is the greatest, this is the second greatest, this is the third greatest. So which is satisfied by this combination, and we have successfully found that. So we are going to return, we are going to come into this condition, and we're going to return true, right? That is why this question is that is why this solution will work in order of n time, and is and I have given you a dry run so that you can understand why the solution will work. So the time complexity for this one will be order of n, and space complexity will again be order of n, because we are using an auxiliary stack, right? So yeah, this is the question. Thanks for actually this is the daily question of our, yeah, so this is the daily question of LeetCode of May. So yeah, thank you guys for watching.